I lost my network. Oh, no. Okay, I think I'm back. My network went. Okay, the meeting is being recorded. I will clean, upload at the end, share a link with you. And the link, please, please, please be cooperative. Do not share a link with anybody else that hasn't paid for a service. Otherwise, you may just disappoint me, and I may stop recording the meeting. For your sake, because we can't meet physically, so we can't meet physically. So I had by all means to upgrade to a paid version of a Meet, so that these meetings are being recorded. Right. Okay, with that being said, I hope you guys do have a calculators with you there. Kindly just once more give me a thumbs up so that we start the meeting. Once more, please give me a thumbs up. Is everything okay? Okay, this is okay. Msonda, Erica, is everything okay there? Is everything okay? Please give me a thumbs up. Yes, sir, it's okay. Yes, I appreciate your response. Others? Msonda, Erica? Hey guys, can you hear me? Besides Lisi. Okay, good. Numerical analysis.
For me, I can't hear anything. You're breaking. When you hear that, Erica.
Even right now, you can't hear me? You can't hear me even right now? Maybe it's on my end. Uh, yeah, I can hear you. I can hear you. I see. Okay, let's do this. Lissy, is it the same thing? You can't hear me as well. Okay, maybe Erica, your hand is up. I can't see and hear anything. I can't hear, but you're breaking, and I can't see. Okay, up to now, because I'm talking, up to now you can't hear anything. You can't hear anything. Msonda. Msonda. Okay. Um, okay. So we actually start. Sonda, we will share the link with you. Please be um, uh, hold on. I said Erica, but I will share the link with everybody. It doesn't mean you leave the meeting. I think she's having network challenges. Okay. So please, really sorry for the inconvenience caused in the afternoon. Uh, yeah. Um, okay. So numerical analysis. Basically, we are talking about now a math into programming. You had discrete math um, basically last semester. Yeah, you had discrete math basically last semester. I hope Erica. I hope Erica, you can now hear me. I hope so. You can also see the screen. Nonetheless, the meeting is being recorded. You guys will have a link to my channel. Please keep this link to yourselves. Just give me a few seconds. I just get my calculator. Very important. I have to have it with me. Okay, thank you for that. So basically, just a bit of background. That we are going to have, and this is the background which you never have in class, but very necessary for your understanding. Okay, I put in work because we have to, at the end of it all, make sense out of nonsense, right? For the lack of better terms. So numerical methods. Basically, we are saying suppose an equation is given as x squared minus 4 is equals to 0. This is an equation. Okay. So this is basically a function or the equation. Remember, we can also say f of x here equals that. Then we say y-intercept to be 0 so that we find the value of x. I think we are all familiar with this question. I have to pose a question there. Please unmute yourself or yourselves. How easy or difficult finding the value of x in this equation or in this function? How easy or difficult? Can you now hear me, Erica? You can also see the screen. Good. So let us start with you. How easy or difficult finding the equation for this? I mean, the value of x for this equation. Almost every equation has an answer, but how easy or difficult it is generally finding the value of x in this equation or in this function. Very easy, not so? Thank you. Why do you say it is easy? Okay. Though a bit of a bit ahead. What type of equation or function is this? What type of equation or function is this? Right. So just like you've said is easy, we realize that x is a square. 4 can also be squared. That's the route we can take. So this is the difference of two squares. I hope we can see that. So this function is a function of difference because of minus. This is square. 4 can also be square. So it is a difference of two squares. So when you have a difference of two squares, there are a number of ways we can work this out. We can cancel out the powers and find the value of x, or take the guy the other side and square root it. Okay, so what we are basically saying, the equation can be solved using analytical method or numerical analysis. Basically, this equation is the difference of two squares, isn't it? Your hand is up. Please go ahead. Hello? Your hand is up. Please go ahead. Okay, so this is the difference of two squares to begin with. So this equation or a function can be solved using two methods, the analytical method or numerical analysis. So we will talk about the difference between the two in just a moment. Okay, because 4 is a perfect square. So how do we solve this? We can apply rules of algebra. Basically, we have that, we square that. Then, because it's the difference of two squares, we can say x minus 2, this first part. But when you get a minus, what's left is plus. It means we have two x's and two 2's. Okay, so there are two x, so you have this x and another x. You have two, these two and another two. That's what this guy means. So you group these first of all, x minus 2, which is that. Then once you get a negative, what remains is a positive. So on the other side we get x and 2, then we get a positive. Then each bracket we equate it to 0 and x minus 2 or x plus 2, making x the subject of the formula here. Basically what we are saying, whatever we add this side, we also add this side. So negative 2 plus 2, this will give us 0. It's same as taking 2 the other side. 0 plus 2 is 2, and you're gonna have a 2 there. Here, because we have a plus, we subtract this. the same way we subtract there, we have a negative 2. Very, very easy, and we have x equal to 2 and x is equals to minus 2 there. Yeah, there are a number of ways. If we wanted, we would have just taken for the other side, then square root it and say plus or minus the square root of 4, and you have these two there. Did we lose anyone? Did we lose anyone? Are we good so far? Please go ahead. Please go ahead. Go ahead, please. You've lost me. Where? Okay. Please go ahead and unmute yourself. You can hear me now? Can you hear me now? Can you hear me now? I'm talking. Can you hear me? You can see even the screen? Okay. Please mute yourself. Thank you. Okay, so what we are saying is this is very easy because you'd find that this is a difference of two squares. You have x squared and 4. 4 can be squared. 4 can be squared. Okay, so this is the difference of two squares, right? So we can solve this using two methods, okay? The equation can be solved using analytical methods or numerical method or analysis. Okay, so because 4 is a perfect square, so you'd find that you have a difference of two squares. And this is what we are basically doing. So x squared minus 4, basically 2 can be squared. Okay. Okay. Okay, good. So basically you can say x minus 2, which is this, then x plus 2, which is that, then eventually find x is 2 and x is negative 2 there. Are we okay, Erica? Are we okay now? Somehow where exactly? Okay. Nonetheless, can we work out this equation in this manner? Because that's what we were explaining. We can. Okay, that is basically what we were explaining. Very, very important. Very, very important. So, supposing we are together, basically supposing we are together, because we are trying to give the background. Okay. So example 2, suppose we have been given an equation like this one. Like this one. X squared minus 2 equals 0. How easy or difficult it is to solve this equation? Finding the value of x. A question there. How easy or difficult? How easy or quite difficult? That's true. Msonda. How easy or difficult? Very easy. You can do that without using a calculator. Without using a calculator. Let me put it that way. How easy or difficult is it to solve this equation without using a calculator? Finding the value of x. Yes. Yes. Very easy. Okay. What's the value of x without using a calculator? Ah, good. In how many minutes? In this x squared minus 2, what will be the value of x? Okay, x is equals to 2, or x is so is there a difference between this equation and this equation? Is there a difference? Or there is none? Between x squared minus 2 and x squared minus 4. Why do you say there is no big difference? Here. Okay, good. Is it the same here? So how easy or difficult it is finding the value of x in this equation? Very easy. Okay. Try and use a calculator. Try and use a calculator if you have it there. Okay, anyone with a calculator to solve this? Because I have it myself, but I want you guys to solve. Anyone with it? Lissy, do you have a calculator? Erica, do you have a calculator with you? We want to build a solid foundation. That's the reason we started with this. Lissy, Erica. Okay, please help us with the solving. What's the solution? Same thing. Just take this negative the other side, then square root it to cancel this. What's the solution? Let me let in someone. Okay. Okay. You've gotten a calculator now, Msonda? Okay. Same thing. Just take this negative, the other side, and square root it to get rid of this square. What answer do you get? Using a calculator? You take this the other side. Erica, can you hear me? We are in this on this equation here. X squared minus 2. That's where we are. Yes. One, 3, 5, 6, 2. Not so. Good. So how easy is it finding that answer without using a calculator? Not very easy. Okay. That is basically what we are going to be talking about in this course. Okay. In programming, there is nothing like precise answer. So a calculator is a computer. So we are going to go into the mind of this calculator and process by ourselves what is happening in the background. That's basically that is the general overview of this course. Okay, in as much as we are going to be using a calculator, we are going to talk about how. We are not going to be talking about equations like this one which has a perfect square. No, we are going to be talking about equations. Please go ahead. Yes, that's why I keep emphasizing, please have a calculator. Erica, please go ahead. Okay, though it's a wrong spelling there, nonetheless, we've communicated. Please go ahead, Erica. Your hand is up. So you would find that it's not easy for us to work out this such an equation. Why? This is because solving this equation isn't that simple as 2 isn't a perfect square. I've put an explanation for you there. So in such an event, we use what we call numerical method. Okay, so there are two types of methods that we use in math. One method is called analytical method. The other method is called numerical method or numerical analysis. Analytical method, okay, is a method which is used to find the equations or the solutions of equations or functions that give a precise answers. For example, in this equation, the answer is either a 2 or -2 or both. Okay, so in that we use what we are calling analytical method. We just analyze that. Can you hear me now, Erica? Okay, we will share the recording nonetheless. Please go ahead. Don't worry, we will share the recording with you as soon as I upload. Are we good? Right. So basically, it's because this then for the equations whose answer is not precise, okay, it's full of decimals. We use what we are calling numerical methods or numerical analysis, and that's what we are going to be talking about. Okay, so so numerical analysis or numerical method are basically methods that are used for getting approximations. So in this regard, we are just approximating the solution for that. Okay, the value of x. We are just approximating. Someone can say 1.4. The other person can say 1.41. The other person can say 1.412. The other person can say 1.4142, and so on and so forth. So we're talking about approximation. Now we go into computer. Remember, in computer, when you say 5.0 divide by 2, in computer science, what solution do we get for that? What solution are we getting for that? In computer science? No, in computer science, in programming. Not 2.5. Please go ahead. 5.0. Yes. Yes. Divide by 2. Divide by 2. Or divided by 2. Okay. So, okay. So in programming, please, this is the concept. You do not say 2.5 in computer science. It's 2.49999999999998. Never say 2.5. That's very, very important. I know we talk about this concept of saying no 2.5 and the like, but when it comes to computer science itself, we talk about 2.999, 2.4999 and the like. Okay, so we're doing the approximation. So numerical methods are just methods that are used for getting approximations of solutions to functions that cannot basically that cannot be solved analytically. We can't solve this by analytical method. Very, very important. I put you a note there. Note, I was supposed to say E here. Not only functions. Say, okay, this is a note. This is fine. Not only function. Say for instance, you want to solve or find derivative. Okay, this is calculus. This is basically calculus. Did we lose anyone? Did we lose anyone? Okay, good. So, not only functions, but also calculus. Remember, in calculus, you don't get the precise answer in calculus. Never. Sometimes you get an answer in form of equation. Okay? So, not only functions. Say, for instance, you want to solve or find derivative of a particular function at a particular point. There are some functions whose derivatives are almost impossible to be derived or to get, and we are going to look at such examples. So there are also some integrals. Okay, basically they are derivatives where you say, okay, you multiply the power with a number, then you reduce a power and something like that. You also add a number to the power, then you divide by the new power. I hope we remember the integration. We are going to look at these at a later stage. Okay, so some integrals that are impossible to be derived using analytical methods, it does not have a solution. The solution can be achieved through numerical means or method or numerical analysis, and we're gonna look at this, whose job is to simply approximate or give approximation of the solution. So approximation rules, these are rules that you must know at heart. Okay, approximation rules, they will never give you these in class. If you had a class already with DMZ, you will never talk about this, but you are expected to know them. Very, very important. So approximation rules. Okay, number one, you have to establish the range, basically a small range in which the solution might lie. We will look at that in a moment. Let's say you want to find the solution to this. Okay, you have to come up with a range in which the solution must lie. I'll give an example. The solution for this equation basically won't be 0. It can't be 0. And it can't be 2 because 2 is the last value. So basically, in the range between 1 and any number less than 2. So you can have 1 to 1.9. This is where the solution is going to lie for this. That's why you have 1.4 there. So you can't say the solution here is 0. That is impossible because this is a number. Then you can't say the solution is 2 because 2 itself is the last value. So you have to come up with that range. You have to establish the small range in which the solution might lie. That's the first thing you do. Okay? Then you apply the analytical or numerical method, or you apply the numerical method there to close in solutions within that particular interval. Don't worry, we're going to talk about what an interval is. Basically, an interval, oh no. Power is gone, but I think we are going to survive. I think we are going to survive at up to a particular point. Okay, I think we're gonna survive. Yeah, we will survive. Yeah, we will, basically. Okay. What's the issue with power today? What's the issue with power today? Did we lose anyone? Did we lose anyone? Okay. So number one, establish the range. Adjust the small range when your solution must lie. Then come up with the interval. Okay. The interval is basically that same range. For example, for this, we are going to say the solution is within 1 and number 1.999, but less than 2. We will talk about that in a bit. There are 4 rules. The third rule is, in many cases, the exact value is not found. Therefore, there is the need to specify the degree of accuracy of the approximation that can be satisfied. Don't worry about that. We will look at this in a bit. Then estimate the error introduced by this approximation. For example, if you say the solution to x squared minus 2 is equals to 0, the solution is 1.4141, 1.4142, and so on and so forth. What we are basically saying is there is an error introduced for that. And what's that error? Basically, if you say 1.414, then you subtract that value from 2. You are going to find that 0. Let's say square root of 2 minus 2. You're going to find that 0.5857, that was the error introduced for that. So you estimate the error introduced by this approximation. Are we good there? Are we good there? This is good. Msonda, are we good there? Please give me a thumbs up.
Yes, I'm good.
Okay, good. So that is basically what we are saying. Okay, so to find this now, we rewrite it as a function. So first thing you do, you write this as a function. This is 0 is the y-intercept, and y-intercept is basically the function of x. Write that, which is a polynomial. Okay, this is a polynomial function. A polynomial is just a continuous function. That's basically the definition. This is continuous. So if there is a continuous function and there is an interval a comma b, okay, this is what we meant by interval in this rule. Okay, so apply this method to close in the solution with that particular interval. So basically, you establish the range, and that range we are going to call that range a comma b. we do not know the exact value. So we establish the range there. So if there is a continuous function and there is an interval a comma b, and in that interval, okay, the sign of f of a and f of b are different. So what we are just saying is, when you find the solution for function of a and the function of b, these signs should be different. So one of these, if this will give us negative, this must give us positive. If this is give us negative, this must give us positive. Then it can be concluded that between a and b, there must be at least, or there is a number called c. Okay, so between these, what we are saying is, if this is a negative number and this is a positive number, what we are saying is between negative and positive, there is a number, and that number c is called 0. Remember, if this is negative and this is positive, for us to jump from the negative to positive, there must be a dividing line, and that dividing line is 0. For example, when we solve this function, we're going to have two values. Those two values are negative or positive 1.4142. So when you solve this, you are going to say basically right here, if you take negative the other side, it will become positive. Once you square root it, you are going to have positive or negative the root of 2, and that will be positive or negative 1.4142, and so on and so forth. So you would find that the same number, one of it will be negative, one of it will be positive. And this is what we are saying. So if this is positive and this is negative, or this is negative and this is positive, between these two, there must be a dividing line. And that dividing line is 0. And that is what we are calling a C. Okay? So, so between A and B, it can conclude that between A and B, there is a number C, such that the value of a function at that point is equals to 0. Okay? Which is the root of that particular function. In other words, we can conclude that the graph cuts y is equals to 0 on x-axis, and y is equals to 0 is the c is equals to 0. What this just basically means is, this is 0 is the y-intercept, and y-intercept is basically the f of x. So if this c is the 0, the c, which is between a and b, which is 0, is basically this. So if we put c here, we are saying f of 0. Is that confusing? Is that confusing? Hello, is that confusing? Beg your pardon? Okay, good. Lizzie, is that confusing? Okay, she left. So that is basically what it means there. So C is unique. Okay. Then there is what we are calling tolerance in the degree of accuracy. So this is what we are saying. So when we get f of a, we also get f of b, have different, if these have different signs, between a and b, there must be a value called p, such that f of that p is 0. Same thing. Okay. We will. So we are going to basically introduce ourselves to what we are calling calculus, talk about the limits, and so on and so forth. Okay, so okay, so basically power here is gone. I think we can power here is gone. Okay. I will post in the group. We make it up tomorrow. Supposing power isn't going to be difficult. I don't know why it has behaved like this today. I really don't know. We don't have power issue. We will make it up tomorrow. I will post in the group, and basically I have to look at my timetable. You also look at your timetable so that we agree on time. I think I have about 3 lectures tomorrow, and my last lecture will end at 16. Okay. Are we good so far? Because power is gone. Are we good so far? And I have to upload this video. Are we good?
Yes, sir.
Okay. Let us make it up tomorrow so that we finish the introduction. We have to build the solid foundation for this course. That's why the introduction is always important. We will get back on campus and we will start the physical meetings and so on and so forth. But for now, we have to just deal with what is right there. Okay, have a pleasant evening, and possibly we see each other tomorrow, depending on how the load management is going to be. Yeah, have a good evening.